Hello, ladies and gentlemen. Welcome to Statistics with Mr. Walton, and today we are going to talk about inference using a significance test with P and P hat. So if we look at our notes for the day, first thing we need to realize is that the mean is P. Please recall that the mean of all p hats is equal to p for our sampling distribution. So the mean is p, and that is the parameter of interest. Since we know p, the standard deviation calculation that we use is the square root of p times 1 minus p divided by n. And please realize that we need to be able to show that the distribution of p is approximately normal, that we also need to be able to show that the pieces of our sample are independent, and that we have randomness in the gathering of our sample, whether that's through an SRS or random allocation. Okay. Also, this time we're going to relate it back to what we used to do with normal CDF. If you recall, we used to talk about using the standardized test score or the Z-score. Okay. And if you look at our notes, we're going to now still use it, but we're going to call it the Z test statistic. How do we calculate it? Well, there's a formula sitting right there for you. That's what we're going to do. Okay? Realize again that this means normal distribution, mean of 0, standard deviation of 1. So that is our Z distribution. Okay? As you continue to read, we're talking about our hypotheses. When we talk about P sub naught is indicated with P with a little 0, just like H sub O. I need you guys to realize that that means we're talking specifically about a number. Okay? So when you see P sub naught, I need you to think this means a number. Okay? And I think that that's pretty good. Again, our assumptions are listed here. Please realize, if we're looking, that since we know P, we will use n times P and n times 1 minus P to talk about whether our sample is large enough for our sampling distribution to be approximately normal. Okay? Okay? Also, this is different than confidence intervals because remember we used n times p hat for a confidence interval. So as a reminder, just so we don't get confused and so we can show the difference, our formulas, we have confidence interval and we have a hypothesis test. Are you ready to see an example? Sources say yes. I hear the whispers, so here we go. For number 1, our example. What are we going to do if we have a 1 proportion Z test? Let's look at what we know and what we're going to have. All right. First, looking at the problem, what do I know is true? So I have some summary statistics, and I find that it's a lot easier to identify the summary stats and list them and then talk about what we're going to do and what we need to find. So here's the first thing. Based on what's given, I see a percentage. I don't see anything mentioning a mean, so I know that P is 0.04. Okay? Based on what's given, I know that X is 9, N is 150, and that's from my sample. All right. Next up, can I calculate the standard deviation of my p hats? Yes, I can. 0.04, 0.96 over 150, approximately 0.016. Okay, had a little glitch there, sorry about that. And then can we calculate our z-score? Yes, remember we know that it's p hat minus p over the standard deviation of p hat, and in this case that means it's approximately 1.25. All right, so now that we have all of our summary stats, we need to remember we're conducting a hypothesis test. So what is the parameter of interest? In this case, it's the proportion of defects, right? And our population here is from a manufacturing plant. As long as we have that and we have a parameter that mentions our population, and we are ready to look now at H sub O and H sub A. We always write the null hypotheses in terms of the parameter, so that means we're going to write P. We know that P is 0.04. That 0.04 relating to the notes above is our P naught. So we need to keep that in mind. Therefore, next up is what inequality is mentioned here. We're looking, and I'm hoping you see exceeds. Exceeds means greater than. Okay? Greater than goes with H sub A. Therefore, our null hypothesis is P is less than or equal to 0.04. In context, that makes sense because if I have less than 4% of all of our items that are being produced be defective, I'm happier than if I have more than 4%. So, we are now ready to look at what do we want to do? Oh, one more thing. I didn't give you an alpha level. So therefore, I'm doing this. I'm going to pick the alpha level that I think most of us love and know. I'm going to put it with my summary stats, and I'm going to say 0.05. So after I have this, I am now ready for my conditions. Okay. First, I'm going to remember my mnemonic device, sin, and for S, it is given that a random sample is used. Therefore, randomness is met. Okay? For I, that's independence. How do I establish independence? That's my 10% rule. I believe, so therefore, I'm going to say it is reasonable to assume that the plant manufactures at least 1,500 items, which is 10 times 150. So, my items should be independent. Notice, independent. Notice, you say that there's independence. You don't just assume that I know what you're talking about. For N, normality. I would say since N times P is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. However, we're going to have to make sure we calculate, and if we calculate 150 times 9 over 150 is only 9. Is 9 greater than or equal to 10? No. Okay? But 141 over 150 is greater than or equal to 10, so that one is met. So this condition is not met. So I will proceed with caution, meaning my results may or may not be true. Also, if you want, we'll go ahead and put that our p hat is equal to 9 over 150, just so we have it. And now we are ready, okay, to actually calculate. Well, what are we calculating? Think about it. Normal CDF. So we are calculating what's the probability that p hat is greater than 9 out of 150. And we always want to make a picture, right? So here's 0.04, right? And our p-hat value is 0.06, so it's somewhere right here, and we're shading to the right at 0.06. So when we do this, we find the probability of a sample of 150 with a number of counts of defects at 9, meaning 6% of them. How likely is this to occur? And if we do this using normal CDF, we'll get 0.1056. Now, based on our p-value, I think we know what's going to happen. So what do we have to say? We have to actually have our conclusion and tell everyone what we got. So that's our money statement. Money statement says, based on the p-value, we would reject H sub O. Okay? Therefore, the claim that production is out of control is not supported. All right. Now again, we do have one slight issue with N. So we may need to revisit this, but based on what we've done, we have the ability to write this, and we have said that we are proceeding with caution. All right. Hopefully this helps. I'll see you in class.